So good afternoon, everyone. I'm Brock Johnston. I'm the Public Relations Manager here with the Iowa Soybean Association. We appreciate your membership with ISA as always, and thank you again for joining us today. The Iowa Soybean Association is driven to deliver insights, tools, activities, and information to improve the competitiveness and the profitability of Iowa's 40,000 soybean farmers. Today's webinar specifically is on water quality and monitoring, and it's a part of our larger Innovation to Go series webinars that's led by staff with the Research Center for Farming Innovation. And of course, these are taking place every month until September. So feel free to tune in every month on the first Tuesday. You can check out those dates and topics on our website as well. Today, we are joined by Tony Seeman. He's the Senior Field Services Lab and Data Manager with RCFI. So just a few housekeeping notes here before we hand it off. So today's webinar is designed to be highly interactive. So first we'll hear from Tony and his presentation, and then he'll be available to answer your questions directly in the Q&A portion that's going to follow his presentation. So if you do have any questions throughout the presentation or after, please share them using that Q&A feature that you can find at the bottom of your screen. We'll be gathering those up throughout the presentation, and we'll just share them during the Q&A portion. So with that, I will hand it over to Tony to get started today.
Thanks, Brock. As he said, I'm Tony Seeman. I'm the Senior Field Services Lab and Data Manager. I've been on staff here at Iowa Soybean Association for just about 16 years, engaged in water quality monitoring in a variety of roles and projects. And so I'm going to talk about some of the results today. To give you just a little outline here, I'll give a little introduction of what we're going to talk about. I'll go over some of the 2021 stream results. We'll talk about some of the longer term data we have, looking at what we saw last year, put it in perspective in terms of the drought. We'll give a quick historical tile look, and then we'll talk specifically about a few categories and some things from 2021 in the tile water monitoring. Why is this important? Why do we want to monitor water quality? Well, kind of in the general sense, in the big picture, we want to document conditions. We want to get a baseline. We want to understand how much nitrogen specifically. This talk is going to focus exclusively on nitrate nitrogen. But to get an idea how much we're losing from our farm fields, how much we're losing from different areas of the state, and then put that in perspective over time. And so do we see any trends over time? Are we making changes that are improving, or, are the conservation practices we're installing, are they effective? And then down to the kind of the individual tile and to the individual farmer level, how can we quantify the nitrogen movement on your farm and look at it in terms of nutrient management and how well we're performing, and if we can make some improvements there. And all of that with an eye on meeting the goals of the Iowa Nutrient Reduction Strategy, again, trying to impact the Gulf of Mexico. And so a couple concepts quickly to talk about. So I'll be talking about both concentration and load. And so concentration is the amount of nitrate per unit of water. So this is what happens when we take a bottle out, we just grab a little bit out of the stream, we bring it back to the lab, and we run it through the machine, and we get a result for what was in that bottle of water. And so that's milligrams per liter or parts per million. And when we think about contamination and loss of nitrogen and nitrate, that at that point, that's really an acute issue that really pertains to the drinking water aspect of the rivers in Iowa. And so, we have seasonality, things freeze up over the winter, it thaws in the spring, we get rainfall, then the crops start growing, and we have this cycle. And so at some points in the year, the amount of nitrate in the water here in the Raccoon River that's being pulled for drinking water will get up over that 10 milligram per liter maximum contaminant limit. And so that's when regulations kick in on the drinking water utilities, and they've got to take action and send notices and change their operations to get through that time until the water drops back below that 10 milligram per liter level. When we talk about load, so that's where we bring into the amount of water. And so this is kind of the total amount of nitrogen over a period of time. And I'll specifically be talking in yield. So that's kind of a similar measure. It'll be the total amount over a period of time per acre, kind of a way to standardize it between different areas. And so Talking about the load or the nitrogen yield is really the chronic issue. And so this is more what the nutrient reduction strategy is aimed at. We have different amounts of nitrate in the water going down the river, but there's always some. And so if we have more water and we have a higher concentration, we have tons and tons of nitrate moving its way on down to the Gulf of Mexico, and also local ponds and lakes and streams, and fueling algae blooms and eutrophication, and causing those issues. Another thing, trend, the most common question I get with water quality is what are the trends, or at least second after what's the quality of the water right now. And when you'll see when we look at some of the data here, anytime we're looking at environmental data and specifically water quality data, there's a lot of variability. So, and you can just think of how much is in the stream. And most of the time, your local stream is running at a normal level and it goes down at the end of the summer. But you think about the drought years where the stream may completely dry up, or it's just a trickle. And you think about a flood where the stream is out of its banks and rolling across the landscape. And so, when we're looking for small changes or things that happen within that large amount of variability, it's real tough to see. And so I'm not going to talk too much about trends today, but a couple of things I did want to mention about it is, one, if you've seen any of my presentations or any of the publications I've done, I really don't like to use straight lines with a lot of stuff. Unless the data really shows a straight line, there's really not much reason to think in a straight line. And so you're not going to see anything with a straight line fitted to a big cloud of data saying that there's some trend. We really need to take as much variability out, describe as much of that variability before we can really attribute something to a natural trend. And so generally I use a low S curve, but basically it's a nonlinear way. It's kind of analogous to a moving average. So we can see what things do in different ranges of the data, and we can see breakpoints, and a lot of times we'll see things are flat over most of it. And so the last thing is significance or statistical significance. Why do we need statistical significance? Well, there's two big reasons. The first is because we're sampling data, and so we're only doing a subset of what's out there. We're not sampling every stream mile or every single tile or every single field. And so, we need to make some assumptions based on our sample and how it relates to the larger data set of all of Iowa. And the other one is because of variability. Again, I go out to a field, I go to a tile line, I pull a sample, we bring it back to the lab, we get one result. I go back out a month later, and I'm pretty sure the result's going to be different. Just like when I'm done grabbing that sample, I'll go down a couple miles down the road to another field, I'll grab a sample there, and it won't be exactly the same. And so as we have this variability, we need to make sense of it. And so how confident are we that when we see one set of data is higher than another, do we believe in that data? But what I want to emphasize about that is that we don't need to completely be bound by statistical significance. Part of this depends on what the decision we're trying to make, and so we want to really be very confident and believe in that what the data is telling us is what's really happening out there when we've got really risky decisions or high investment decisions. Whereas if it's something that we think generally is correct and maybe we just haven't collected enough data to show it, I wouldn't wait on a 95% confidence, statistical significance to say, yeah, we should do that. It's kind of like, would you need 95% confidence to maybe run your drinking water through a filter pitcher? Well, most people wouldn't wait. They'd just say, well, it's $30 or whatever for the pitcher, I'll do it. But if you want your local water plant, is going to have to drill a well to a new water source. You're going to have to install a new treatment thing for tens of millions of dollars. Well, then we want to be absolutely sure in that case that the data is telling us that, yes, this is a decision we need to make. And so I'll be talking in terms of statistical significance, kind of in that classic form, that grew out of, experiments in the lab and how do we, justify the difference on the variability. But, for some of these decisions, it could just be a matter of needing more data or a broader set of data. And so if it's something that you think directionally is correct, we don't really necessarily need to put all the confidence in the world in the significance. So first talking about stream sampling, Agriculture's Clean Water Alliance has been doing snapshot stream sampling since 1999. in the Raccoon River. They expanded to a broader area, basically all the source water above Des Moines in 2007. And so from 2007, we have data on these watershed areas you can see on the map. And so some of the sites are co-located where there's gauging stations where the USGS or other partners measures the amount of water that's going by there. And so again, these are locations where we can look at kind of the cumulative effect of the water and the concentration. So we have concentration data from these sites. And so we can calculate with the total amount of water and have an estimate about what the amount of nitrogen leaving these are. And so for 2021, not surprisingly, things were very dry. And I'm going to move a little bit backwards here on this one and start with the end yield. And so you can see these bottom dots are what represent 2021. The boxes represent all the range of data from 2007 to 2020. And so we can see in all cases but one, it was the lowest amount of loss registered. Really, we're looking at 1 to 2 pounds per watershed acre that we lost there. And so really kind of unprecedented in terms of what we've been looking at over time. And we'll look at that a little more as well. But I'm going to be showing quite a few box plots today. This is a tool that we use when we're analyzing data to kind of look at more than just one number. You know, we don't really, an average doesn't really tell the whole story here. You know, box plots can tell us not only kind of what the central value is, but can also tell us relationships between sites and kind of look at this range. And so, you know, just looking here, those two sites in the center left are on the Boone River. And you can see that they often are higher than the other sites, but they also have a pretty big spread. And so they get really low as well. And so that's, you know, something unique about those that just looking at the average doesn't tell us. But what you should really think and what a box plot is representing is this right here. These are the individual years of data. And so you can see box plots, there can be some slight variations, but in general, the middle of the box refers to the central half of the data, and you can kind of see how it spreads and skews. And then those hinges or the arms or the things sticking out a little bit show you the rest of the data, the other half of the data, and then occasionally there'll be outliers that are kind of unique values. And so this is what I'm thinking of when I'm looking at just those box plots, is this range of data. And so concentrations from last year for these 7 or 8 sites, again, similar, lowest we've seen on record for most sites, maybe 1 or 2 of them was tied or just above the lowest. And so again, we can see we're well below that 10 milligram per liter as an average from April through August. And again, just pretty unprecedented, even considering we've had some other dry spells. And so again, looking at the water yield here, similar story, 2021, very dry. I mean, we're looking at, this is water yield. So this is on an acre inch basis. And so, you know, we'll look at some rainfall data in a little while, but we got, you know, 15 to 20 inches of rain, and we had 2 to 3 inches of drainage. And so pretty much all of them were under 2 inches of drainage. And you can see, again, if it's below the box and the whisker, then it's the lowest that we have over that time period. And so in the Raccoon River, where ACWA started, we've got some longer term data. And again, here, I'll talk about a couple different things with this historic. So this is concentrations going back to 2000. I'll put 1999 on when we're looking at some of the drought stuff. But you can see here, there's not really a clear trend or a pattern. I guess if there was one, you could maybe say it's a sawtooth, where we see quick increases and then a slow decline, and then quick increase and a slow decline. We can see that it bounces above and below that 10 milligram liter per limit. And so this is on average. And so this is, you know, we can see we do have drinking water issues here at Des Moines. We see the North Raccoon, which has more tile drainage and is flatter, and a little bit more row crop acres, is pretty much always higher in nitrate concentration than the South Raccoon, although some years it's pretty close. And looking at the precipitation here, this is April through July precipitation, but doesn't really necessarily match that pattern. We see some of the years show up as dry that we expect. We see some other years, you know, this is kind of looking at a smaller window than exactly what's needed for crop production. But again, here we see, I guess if we were going to say there's a pattern there, we kind of see the flood years of 2008 and 10 stand out, and then kind of lower before and after. So those two things don't really match up. And so When we move forward now here to the nitrate yield, this is where things get interesting. And we've got this long over 20-year record here. And again, we don't necessarily see a pattern. I guess we see a pattern that the North Raccoon generally loses more nitrate per acre than the South Raccoon. But again, some years based on the rainfall and some of the other patterns, it's pretty close. Other years, the North Raccoon's quite a bit higher. But, you know, just trying to think through what we're going through now with the drought here, we see we've got two kind of previous droughts where we had levels this low where we were literally losing 1, 2, maybe 3 pounds per acre from April through August. And so this is kind of the prime loss time in Iowa. The majority of the nitrate moves in May and June. And so is there anything we can learn going into this year looking at these droughts? Because when we look at what happened after the drought, you know, while the droughts look the same and when it's really dry, we don't get a lot of nitrogen movement. We do see that the year after those droughts is somewhat different. You know, in 2001, we kind of went back to what is kind of maybe the steady state, especially in the North Raccoon, where we're losing about 20 pounds per acre over this time period. 2013, though, on the other hand, after the 2011-12 drought, we saw the highest loss on record for this time period, and we were pushing 35 pounds per acre just over these 5 months. And so that's pretty significant loss, especially when you consider that this is just per watershed acre. So if we're assuming that the majority of this is coming from crop acres, that would be even higher per crop acre. And so, you know, and then when we think about the rest of the year and that we were wet after that. And so if we're looking at the amount of total loss would be all the way out of this, you know, it would be much higher than this even. And so what could kind of explain these things and what does it bode for what we're going to see this year? And so I've been kind of looking at this over the winter. And here's the precipitation comparison of the 3 years here. And so that 2001 coming out of that drought is that purple line. And you can see it was pretty steady and nothing really dramatic. And when we look at that blue line, though, that's 2012 going into 2013, you know, right here we see a quick uptick. This is cumulative rainfall. And so we see that big vertical line, which this is from the Jefferson rain gauge. And you know, there in late May that year, we had a 5-inch 24-hour storm and multiple several-inch days around that. And we really just got hit at kind of the worst time there in late May before the crops had really taken off and there was a lot of nitrogen vulnerable. And so it was flushed through, it recharged the groundwater table and really sent those levels sky high for 2013. We can see we're actually ahead of the pace here now with that orange line for 2021, 2022. And it remains to be seen, but we're starting to set up into a similar pattern here where we're cold, we're wet, and we're not getting the crops in. Oh, sorry about that. And the other thing, again, is when we had that nitrogen there that was vulnerable to be lost, we also did not have crops in the ground in 2013. If you remember, it was really cold and wet, similar to this year. And so this is the corn emerged percentage. And so those lines are kind of showing the 2 years at the 99%, when basically all the corn was planted and it had come up and emerged from the ground. And you can see there in 2001, it was a little bit on the later side, but we were pretty much going in early June, whereas 2013, we didn't get all that corn germinated and out of the ground and up until late in June. And so those two things, we had a landscape that had a lot of hot, dry weather in the fall that kind of mineralized extra soil nitrate that could not be taken up by the plant. It was just kind of held in place there. And then we got rain before the next spring before there was anything there to take it up. And so that's kind of the perfect storm. And I've been kind of talking about this over the winter and been telling people that I don't think it's going to be as bad this year. The one thing that is different this year compared to 2020 or 2011, 2012 drought is that we had really good yields. And so not as much of that nitrogen hopefully was left over in the soil. We got as much of it in the plant. I don't know how. We certainly didn't have any extra moisture, but in many places we must have just had enough to get it mobile, get it into the plant, and not there just sitting in the soil waiting to be leached downward. And so what does the data look like? And so hot off the press, we've got some April 22 results here. Those two sites over to the left are the Des Moines River and the Beaver Creek tributary of the Des Moines River. You can see they're kind of in the lower, not super low, but kind of in that middle range. If you look over to the four sites on the right, they're the north and south and middle Raccoon. You can see we're kind of on the lower end. Again, nothing exceptional, but those two there in the center left from the Boone River, those were the two samples that just came in a few days ago from Thursday, and we see we're starting to climb after some of these recent rains. And so again, I'm hoping that we're not going to be setting all-time highs with any of these sites this year, but we certainly have some concern the longer that it goes before we can get crops in the ground, get them growing, and get them trying to capture that nitrogen before it leaches down below the root zone. And so now I'll shift gears a little bit and we'll talk a little more closer to the farm here, tile water quality, and I'll talk about some of our data. A few things to keep in mind here when we're looking at tile water data is obviously confidentiality is important to us and our producers. And so I'm not really going to be sharing any individual results today. At some point, I would like to put together maybe a case study where we can look a little more at individual sites and changes that we've seen. But for this presentation, I'm just kind of going to aggregate things and just kind of show some general things that we see. All the samples are analyzed here at our certified lab. So we are certified by the state of Iowa for nitrate. And so we have a full quality control program. And so we're confident in our results. This is definitely good data. These tiles are from working farms. And so with that comes a lot of variability, and we're really capturing everything. And we also get what we get. This is just observational data, unlike some of the research that you may see coming out of the universities where they're really fine scale plots where they really control everything to be the same except for whatever, practice or category or whatever they're looking at. We don't have that luxury. So we're really kind of doing more of a data mining and just looking for overall patterns rather than looking at things within the same field. Some tiles drain multiple fields. And so while it's important, gives us good information, it can help somewhat with decision making. When we're really trying to drill down, it's hard to ascribe any particular management practice to those sites because there's multiple things going on that are all a cumulative effect at the bottom. And then finally, flow measurements are great. And again, that lets us take it to kind of that next level where we can start looking at the loss over the whole season rather than a few little spots in time. But some tiles just don't lend themselves. Some locations aren't just able to. And so, it's still data worth collecting, but it doesn't help us as much try to really draw some conclusions. And this is, I think, what's kind of important. And so looking at our tile monitoring data here, so we really kind of ramped up the tile sites in 2014. And so over that time, when we pull up the database and go to do some analysis, we have 2,100 different sites, and years of data. So, one site, 5 years is 5 site years. But then usually we try to work with averages. We're trying to replicate the conditions, not the actual samples. And so for a long time, we would throw out anything that had less than 4 samples. And so that took us down to 1,631 sites that we have that. These last couple of years, we've had so many dry tiles and so many issues that we've had to be able to do any analysis, we've had to relax that to only 3 samples. And while it still gives us something to compare on, it's not as good of, we're probably not capturing as much variability as we would like when we're comparing those. Then we drill down from there, and we want to know the management information, what was done on that farm. Well, now we're down to 1,158 site years that we actually have good management information that we can refer to on what was on that field. But then if we want to look at specifically what the difference is between cornfields and bean fields, we really need that tile to only drain that. And so again, when we pull out those ones that drain kind of 3 or 4 fields or drain the 80 across the road too, now we're down to 832 site years of data. And so when we look at those and how many do we have flow data with, well, now if we're going to try and look at an overall loss, we're down to 529 site years of data. And then whenever we start kind of our analysis, we're looking at factors to help describe it. And, kind of intuitively, every year is different. And so almost anything we look at, the year pops out. What year was it? Will tell you a lot about the data. And so what that means is that we can't really just lump every year together to look at something. And that makes sense intuitively. I mean, we don't really want to look up in Wright County at a site that had corn and cover crops on it 4 years ago and compare that to last year somewhere down in southeast Iowa and say, well, is it higher or not? You know, it really, each year is kind of its own unit. And so we average about 135 sites that have 3 or 4 samples, that we have the management information that only drain a single field. And then a subset of those actually have flow data. And so just a recent example, after the reports went out to our participants, had one of them get in contact and said, well, you tell me that there's this much of a difference in cover crops, but how does that look across the rotation? And so I took a look for 2021. And so when we look at the numbers there, I had 12 corn following soybean fields with cover crops and 31 corn following soybeans without cover crops. And so all of a sudden, when we really drill down to try to ask these questions and we're looking at multiple variables, all of a sudden that 2,100 site years of data gets really thin. And so while we have an impressive database and we're proud of it and we're going to continue building it, we are a little bit limited still on trying to do some of the multifactorial stuff that we would like to get to the point of. And so we got to keep that in mind when when we have really complex questions that we're not yet able to answer with data. And so quickly, just talking about the interpretation of the results. This publication came out in 2005. It was really the first, definitive paper on the subject. It's really data driven. It's out of Indiana. It uses 5, 6, 8 years of data. And so this was kind of where we started when we were looking at, well, how do we make sense out of this? And basically, when we looked at it and looked at what we had, it really lines up pretty well. And I think this is, we think this is pretty useful. And so I'll just start right here in the middle, because this is always kind of the question you get with tile data is, well, what should it be? And so we use the same categories. This 10 to 20 milligram per liter on average is basically what we expect to see with row crop production, with N at the optimum rate, or soybeans. And I'll talk a little bit more about that. But this is what we would think we would get, and it intuitively makes sense when we think about the late spring soil nitrate test. If we're really trying to target proper fertility at the right time, we're looking at about 20 parts per million of nitrate available in the soil to the corn plant. And so that translates to about 10 or 15 milligrams per liter in the water when you consider what can be lost from that. And so and then it goes down from there. So when we look at the 5 to 10, that's what they saw and what I would agree with, what we see when we kind of put cover crops in. When we get above 20, that's where we're getting too much N applied and we're losing it. Or it may not even be a matter of the rate. It may be a matter of the timing or the form or how we're getting in there. Or again, they brought up the fact that environmental conditions can have high mineralization on top of applied nitrogen fertilizer, and that can be available to be lost if they can't get into the crop. And so we took these, we've kind of modified them a little bit. We put them in categories that basically match up with these. We have similar ones for the nitrogen yield as well, if we have that information, where we can look, again, less than 10 pounds per acre over the year is kind of our low range. Our medium, our 10 to 20, our normal crop production is about 10 to 25 pounds per year. And then above 25 pounds per year per acre is where we're kind of getting into that high range, very high. And so the recommendations that we're going to make based on that are different for what kind of a range. And so again, when we're in that low and very low range, often we already have cover crops integrated, and that's part of the reason that they're down there. But that's a good reason to say, if you don't have that, that's one thing that you could still integrate, probably keep yield the same and keep loss low. One other thing I want to mention about that 10 to 20 range is that it's one of the things that's really useful is it's broad enough that it can kind of capture the difference between these dry years and wet years, as you'll see. And it also is broad enough to kind of capture all the regions of our state as well. And so we'll talk about that as well. But, there's some places we expect it to be a little higher, but even in areas that maybe aren't as productive, we can still see that 10 milligram per liter or above range being where we would be for crop production. And so, as you can see here too, back to the recommendations, when we get to average to that, that optimum nitrogen rate, we're still seeing loss that's more than we would like. We still want to see the reductions in line with nutrient reduction strategy. And so that's where we would begin to target edge of field practices. And so that's kind of we don't need to spend the money to treat water that's already coming out pretty low. But when we do see water coming out, even if it's just normal crop production, that's where we really want to target edge of field practices. And then when we get to high and very high, that's when we really need to look at the nitrogen management. And so that's when there's probably an economic argument to be made that we need to adjust things because we're losing more than we should be. And that's not good. That costs money, and it's probably affecting yield as well. And so based on where you are is where the kind of the recommendations would lie here. And again, cover crops could probably be integrated into most of these systems. And so we promote that. And the thing about cover crops as well is that there's additional soil health benefits. And so if you're already in that low or very low category for nitrogen loss, for one reason or another, probably has to do with the soil and the water movement in that location. There's weed suppression reasons, there's soil health benefits, those infiltration benefits. And so again, that's really kind of the practice that we could see in the most places, in the most operations, and that could have an impact. So here is the data from about 1,800 of those site years of data. And this is looking at the probability of any level. And so this graph is kind of flipped from what you're used to. The average concentrations across the bottom there, and each dot is a site year. And then I've got the categories marked out there based on what we saw. And so the key thing here, again, when we think of that 10 to 20 milligram per liter average, that's where we expect most sites to find most sites. And sure enough, over half of the tiles we've sampled from 2016 through last year fall in that category. And so that lines up pretty well with what we think, that we're using pretty good nutrient management there, but because we've got tile drainage, because we've got high nutrient soils, we're still going to see pretty significant loss. And again, only 12% fall in that high and very high, where we would really look at that and say, we really need to change the nitrogen management probably in a significant way there to try and impact this, because any of the rest of that, you're probably going to lose yield, you're going to lose fertility if you try to tweak it too much. And so those sites would be the ones that we would target. When we switch over, this is about 875 of the sites we had flow data for, and we could do the calculation. And so this is the same categories for the nitrate yield. So this is pounds per day. I think it runs basically April through September, October roughly would be the time frame. And here we see some more spread. And so we have 34 that are kind of in that medium range. We have a higher percentage in the low to very low, but then we've got over 25% in the high and very high. And so some of these could benefit from some nutrient management, but what this graph is really looking at is this is where we would target edge of field practices. And so when we take into account areas that have a lot of drainage or drain maybe particularly heavy soils, these are the locations, these high locations where we would be targeting edge of field practices and where we want to invest in the infrastructure to have an impact and hopefully see large reductions of that. So going now just to 2021 data here, the big story was dry tiles. This map shows the 300 and some complete total sites, not just tiles, but also bioreactors, saturated buffers, ponds, and wetlands. And what we see here, the size of the circle shows the percentage of the visits that the tile was not running. And so a lot of these projects have different timings and different amounts that we're doing. And so it expresses a percent, but basically those very biggest dots you see are sites where it was dry 90 to 100% of the time. We maybe only got one sample out of it for the year. And so again, you can see how when we put all the data with it, we only have 109 sites for some of these things to really look at, and even less if we need flow data. And so again, multiple areas of the state, really only that southeast part of Iowa had sufficient rainfall to really make the tiles run year round. And so when we kind of group these, the first thing we look at is the landforms of Iowa. In some years, we've had other landforms covered. This year, we pretty much only had good quality data from the three main ones. And so the Des Moines Lobe there in blue was significantly higher than the other two, the Iowan surface and the southern Iowa drift plain. This is pretty typical in most years, that's the case. In some years, the Iowan surface, which is kind of by most measures in between the Des Moines Lobe and the southern Iowa drift plain, is sometimes it's significantly higher than southern Iowa. Other years they're kind of work out the same. This year was the Des Moines Lobe. Sometimes a few years we've had northwest Iowa, and it's been high, significantly higher than the other ones, and sometimes even higher than the Des Moines Lobe. It just kind of depends on the year. And so I'm looking at the spread of the data here. Again, we've got, so with these, we don't limit it to only draining a single field because it's kind of draining the landform in general. And so we've got some higher numbers here, but 62 sites in the Des Moines Lobe, 24 in the Iowa surface, and 50 in the southern Iowa drift plain for 2021. And again, you can see that the spread and the variability is pretty similar between the Iowa surface and the drift plain, whereas the Lobe is higher. That median line is above the majority of both of the other two. And that's really not surprising. We would expect that. And so as part of the TAO reports this year, we used some Iowa State data to make an estimate of how much soil organic matter was at these sites in the fields these sites are draining. And as you can see, we get a pretty nice spread here that we're most of the sites in the Des Moines Lobe have above 5%. Again, don't get mad at me if you have accurate measurements. This was just an estimate based on Iowa State data, but we can, as expected, that Des Moines Lobe has those newest, heaviest, most nutrient-rich soils. The Iowa surface kind of in between, and southern Iowa has the older, more weathered soils that have less natural organic matter in them. And so we would expect, in a warm year and with water flowing through, we would see higher losses. But when we look within any of the landforms, we don't see, or when we look at end yield, we don't see any difference. Sorry about that. When we look at how much is coming out in yield in pounds per day, again, we don't really see any differences. There's variability. The Des Moines Lobe's a little bit higher, but because we don't have a whole lot of measurements here, we don't see any significant difference. And moving on to rotation. And so again here, corn following corn was significantly higher than the other two, but really, and this is something we've seen year over year, is pretty common. It doesn't really matter whether you're in the corn portion or the soybean year of the rotation. We basically don't see a difference. And so that really owes to the system as a whole, and to the fact that we have a lot of annual row crops on the landscape. We have a lot of tile drainage. And so as the water moves through, there's always going to be some nitrogen left over. There's always going to be some nitrogen mineralized. It's going to be available for loss. And there's always going to be some water in the ground table or groundwater that kind of made it through and leached in the past year. And so really kind of dispels this notion that when you apply nitrogen fertilizer, you're immediately spiking the tile water. Occasionally we can see a signal after somebody side dresses or after a spring application if we get a big rain, but in a lot of instances, we really don't see a big difference between the samples before and after that. And again, that kind of owes to the bigger system at play here. There was no significant difference within any landform though. Only when we looked at them all as a group did those corn following corn ones higher, when we kind of dropped those numbers down and we only have less sites. For an example, here in the Des Moines Lobe, we only had 6 corn on corn sites to compare to 22 corn following soybean and 17 soybean following corn. And so, if you look at the data there, you would think, well, we're probably getting a little more out of the corn following corn, but we just don't have enough data to tell that story. And that, again, kind of goes back to that frustration of we have a lot of data, but when we really drill down into it, we get some pretty small comparisons going. Again, no significant difference in yield. And here, we can kind of see a signal, like maybe we're losing more out of soybean fields than corn fields. And again, some years I think we might, and that's, again, something we somewhat would expect. Soybeans get planted later. They kind of take up less water, less biomass through the year. And so when we're adding in the amount of water moving through the soil, we might expect to see more water, more leaching, just from those extended periods of water going through with less crop to trap it in the root zone. And so again, if we had double or triple the sites, we may see that, but as it stands with what we have, we don't see any significant difference. And so they really all are just kind of randomly scattered. looking at cover crops. And so this is one that we did see a significant difference in concentration. And this is actually something we see quite frequently. And so you can see there that we still have some spread of the data. It's not that every cover crop field that we look at is under 10, but about 3/4 of them are, whereas about 3/4 of the ones without it are above that. And so this holds for all three landforms. It's significant. And so this isn't really a landform effect. Again, cover crops work. We see this. And again, this isn't to say that these are comparing exact fields and that we could expect X% reduction out of these. That's really for the research community that are doing them side by side. But this is to say that of the fields we have where the operator is using cover crops, those fields are on average lower than ones that they aren't. Again, as I mentioned earlier, when we looked at it for the rotation, we really didn't have any enough data to get statistical significance in the corn on corn. But again, what visual data we have there does kind of suggest that if we had more data, it would hold. But both in the corn phase and the soybean phase of the rotation, the previous year cover crop shows significantly lower average nitrate concentrations. And particularly here, every year, we've seen that. This is a trend that we've seen in our program. And again, this isn't representative of all of Iowa. We work with who we work with, people that want to sample water. And so we're probably a little biased on more people using cover crops than just if we were to pick out sites or farmers around the state at random. But I think this bodes well that the guys that we are working with and gals that are using cover crops are seeing lower results consistently. And so a lot of these are the same fields, not all, but some of these are the same fields year over year. We don't see a significant difference in the end yield, though, and how many pounds we're losing per day. And so this is, there's a couple things here. And so the variability in general, I believe 2016 and 2017 were significant. 2018 was close to a 95% confidence. It just didn't quite make that. And I think some of our lower numbers, and as you can see, the range of values that we saw during these dry years really kind of collapsed that down. But I think the story here, and this is something we see with concentrations too, is when you just look at this, even when it's not significant, it sure looks like when we look at the tile fields that they're more resilient, that we don't see those occasional outliers. There's less outliers and the range of values is lower. And again, I think that's what cover crops being integrated in your operation does, is it can kind of, if nothing else, it can kind of take those worst years out and kind of hold some of that water in place, hold some of that nitrogen in place. So when we do have conditions that are prime for leaching, it's not going to be as bad. Whereas if you just have bare soil and you get the wrong conditions and you have leftover nitrogen or you have high mineralization before the crop's taking it up, we can see really high levels of loss in that. And so, it's, also these are all the fields. And so I didn't narrow these down to only the fields that we had just that field draining it, because cover crops aren't necessarily a 100% coverage anyway. And so we get a little bit more significance when we look at just fields that are completely cover crop versus ones that aren't. But I think, again, even though we don't hit a lot of significance here, I think the graph speaks for itself. And then finally, another thing that we've seen year over year and really kind of catches some people off guard is that when we look at the nitrogen rate to corn, and these are just combined corn following soybeans and corn following corn, because presumably the uptake should be similar for what we would expect in those systems. And again, fitting a curved line here that just kind of follows the data and shows us what it sees. Last year was a little bit more than usual in terms of increasing through that range. But in general, when we look at kind of the range of nitrogen that most people are applying, when we're looking at 130, 140 to 180, 200 pounds, there's really not a strong relationship to the rate of nitrogen applied to what we see coming out of the tile. And again, it's because there's a lot of other things going on in the system that that are really driving this more than just how much nitrogen you're applying once or twice or three times. And so typically what we see is when we have really low rates of application for one reason or another, we'll see quite low concentrations come out of tile lines. When we get really high rates for one reason or another, if somebody doubled up on accident or got some manure late in the year that they didn't expect and had already put something down, we'll see really high results coming out of that. But it's really fairly flat in most years. And even this isn't a strong relationship, even though it kind of increases as we move from 150 pounds per acre to 200 pounds per acre. And so with that, I thank you for listening, and I will answer any questions, whatever we have that's came up on the Q&A if I can. And just a quick plug, we're getting kind of into the year now, but we probably still have some openings for some good sites, depending on what location and how engaged any farmers would be. And so get a hold of me for that particularly. So.
Awesome. Well, thank you, Tony. We will we'll go ahead and move into the Q&A portion of the webinar here. I'm gonna let our attendees ask some questions and have Tony answer them here. So we'll get started here. I'll put one up on the screen. One of our first questions that came in, and this, I think, Tony, you had touched on this a little bit later in your presentation, but if you just want to maybe add a few notes to it here. So this attendee wants to know, can cover crops increase nitrogen loss in certain soil types from the root system of the cover crop by creating that water infiltration that you were talking about?
Yeah, and so we have seen this at times when we looked at no-till systems in particular. There's been that thought, and we have seen, that you may be holding some of that organic matter in place, but it still could be lost in kind of a bigger flush as it decays. We just kind of changed how we collect tillage information. And as you saw from those numbers, we really don't have the numbers to even begin to dive into the tillage question. Also with the variability, we're probably looking at really low amounts. And then again, as I said, these are just comparing cover crop fields with non-cover crop fields. So this isn't saying that the same thing was done to both fields and the cover crop fields came back lower. And so there may be some truth to that. There's some data that backs that up, but I couldn't say for sure that that's a thing necessarily in all cases.
Gotcha. Okay, we'll keep moving through the questions here. And just a reminder to our attendees here, if you have any questions that you'd like Tony to answer, go ahead and drop them in that Q&A feature below. It's at the bottom of the screen that you see there. We'll move on to our next question here. This question comes from Alan. Alan would like to know, is there any relationship of multi-species cover crop and nitrogen loss?
That, we don't have data on that. Theoretically, I would think, in general, just, in just kind of a theoretical sense, the more diverse your mix is, you've got more opportunities to scavenge nitrogen at different times, at different depths. And so I would tend to think directionally that's true, but I don't have any data to really look at that. But I would be inclined to think if you get better establishment, if you get a higher amount of biomass with a multi-species mix, that you're going to get more uptake and better uptake.
Right. Awesome. Okay. And Tony, when you were going through a part of your presentation, I had a question just come to mind from a personal standpoint, I guess. When you're going out and analyzing, collecting different samples and things from fields, what's some of that field management info that you're requesting from farmers typically, or that you're maybe wanting a little bit more background on, just to maybe fill in the blanks on that picture of what those results could be when you're analyzing them?
Yeah, right. So some of the categories I went through obviously are what crop was on it, what's the rotation, did you use cover crops, but we also collect nitrogen management info. And again, we've kind of tried to refine that over time to get more detail in that. One time we just were looking at a total rate. Now we try to look at multiple applications compared to single applications. We want to know tillage kind of regime. We look at the nitrogen form is something. And again, as we get more and more down into the details, we have less and less samples to compare of that, but hopefully over time we can continue to build and we can begin to look at practices that really perform in terms of what kind of timing really reduces loss, what kind of forms maybe are best in certain years or certain parts of the state. What is the impact of tillage? I know it's something a lot of people harp on, but it's really hard to get good data on what is the impact of different tillage practices on nitrogen loss. And so that's basically what we're looking at.
Right. Yeah, I think that also just kind of knocked out another question we had come into. I think for the most part, Doug had asked, how does timing timing of nitrogen affect losses. So
yeah, and again, it's gonna really go in with the 4 R's. And so, timing, of one form, you could definitely mess up the timing on one form. And so it really needs to go hand in hand with what form. If you're putting down liquid, you're putting down UAN, which already has, a significant percentage of it in the losable form. You want to make sure you're putting that as close to when the crop's going to take it up, and hopefully not right before a big rain, because you're going to lose it. Whereas, when we think about anhydrous ammonia and kind of attaching to the soil and being mineralized, converted into nitrate, there's some time there. And so you have a bigger window without it being lost. And so it really is the 4 R's in general.
Gotcha. Okay, we'll move on here. We have some other questions that have come in. So just a reminder, if anyone has a question that's attending today, feel free to drop that in the Q&A feature and we will have Tony answer it for you. So it looks like the next question on here, this is for one of our attendees operation. It looks like they would like to know if my results are in the medium category and I'm using the optimum nitrogen rate, are there any changes that this attendee should be making, or recommendations on that?
Yeah, and so this is kind of a common one. And, in general, well, no, obviously, right? You've got good fertility if you're happy with your yields, if you're being profitable. But there is the part of that Iowa nutrient reduction strategy, and where all the states in the Midwest have been challenged and charged to reduce loss by 45%. And so while we may not, again, that's not where we're looking to really change the fertility regime as much. That's where we're really looking to get that water treated somehow at the edge of the field or farther downstream with wetlands or saturated buffers or bioreactors in places that makes sense. That's where we're really trying to target those practices, because again, we don't want to affect yield. We don't want to take soil fertility and water quality down so low that we're losing yield. We still need to be productive on these landscapes, but we do need to reduce the losses that are leaving our state. And, from a personal standpoint, I will say as well that if starting next year, we had all these things installed and we did see a 45% reduction in losses from farm fields, those trends would be really easy to show. And I could really put some straight lines going down on those. If we think about 45% of 30 pounds per acre being lost, if all of a sudden that year was down to 15 or 16 pounds per acre, we would see things. And so it's a massive undertaking. The scale is enormous. The cost is going to be big, but we gotta plow on, and it's voluntary, not optional, as we say in the conservation community.
Right. Okay, let me pop that one. All right, I'll move on to the next question here. So this question comes in from a attendee. It looks like they want to know about maybe some of the associated costs and details, maybe about participating in water quality monitoring programs with ISA. So if they want to sample, their tile lines for nitrogen, are there associated costs that go along with that, or what does that look like?
Okay, so classic answer, it depends. So some locations, we work with a variety of partners and in a variety of projects. We contract with some, we're actively engaged in others. So there's areas that we actually do water sampling that we could add somebody in if they were in one of those particular locations. If they were in a partner location, we could have whoever's collecting those samples do it. But I do still have some room that I could do some cost-free sites, especially if they're ones where we can get flow data, we can get consistent sampling. I could send some bottles in the mail. We often will do kind of a little seasonal pack with a cooler and a series of bottles where they can collect them themselves on somewhat of a regular schedule, have them freeze them. They can mail them back to me and we can analyze them and get them in the program that way. And then I still also kind of a real low effort, low cost thing. The CDI and Iowa State Extension did a few years back. They did what was called the retain kits with just kind of a self-test with test strips. I do have a few of those around here still. That's kind of something if you just want to poke around and just trying to dip your toe into the water, so to speak. I have a few of those kits I could mail out to people if they were interested and got in touch with me. So it really kind of depends on where you are, what kind of operation you have, where you would fit into this broad water quality monitoring that we have. But we definitely want to try and get people in and And we easily could, if somebody was looking to do a significant project, we do have a fee schedule, and we could work that out depending on what kind of a program they were wanting to do.
Awesome. All right, set of that one. Looks like we might have time for one more here. Let me grab this last question. And if we don't get to all of the questions, we will be sure to, get you in touch with Tony if you have additional questions or want additional info on anything. So this is a little bit more broad. This attendee would like to know, what are some characteristics of those sites that you consider best for sample collection? And then are you able to come out to their farm specifically to take water samples? But if there's additional details, Tony, we can connect you after the
again, it would kind of depend on the location. We've got pretty good coverage in the Des Moines Lobe. So if you're in the Des Moines Lobe, we may be able to get you sampled. We've got a lot of areas that we go to there in other parts of the state. We would have to see whether you're in a water quality initiative area or some local farmer-led things. But there's, again, as we have this network, there's efficiencies we can gain. Even have somebody pull their own tile, and if they can get it to a spot where we're getting samples shipped from or picking them up, we can work that way. So really depends on the location. Specifically to the sites, we would like sites that the tile runs fairly frequently. We would like it to be easy to access. It's one thing to have it on a gravel road or right in the stream bed compared to driving back 10 minutes down a buffer way. We would like to be able to get flow data from it, and be able to get a bucket under it and have it dumping out and not just kind of coming in the ditch or coming in at stream level. And ideally, it would just drain one kind of management area or one field, so we can say what was done on that was the only thing that was affecting that water. And we don't need all three of those things to get engaged, but all three of those are the best sites.
That's great. Okay. All right. And like I mentioned, if there are any other questions, feel free to reach out. We have Tony's contact info there on the screen as well, and we'll be sure to, in any follow-ups, to send out his information as well. So let's see. Well, today's discussion was the third in our ongoing series of Innovation to Go webinars, again, taking place each month through September. So in each of those, you can join researchers at ISA's RCFI for other opportunities and different ways to engage, so you can improve, your profitability and manage your resources on your operation unique to you. So anybody that is interested in participating in a research trial or project with the RCFI team can complete a trial interest form that's located on our website as well. And then we also have all of the upcoming webinars that we're hosting with descriptions and links to register as well on our website. So that is iasoybeans.com if you want to check that out before our next webinar. Our next webinar will be taking place on Tuesday, June 7th, and it's the same time, 12 to 1. It'll focus on a multi-year project that's studying soybean yield, variability, and profits throughout the state. So make sure you tune into that as well. We trust that you found today's webinar beneficial as you continue to make those decisions for your operation. Big thank you again, Tony, to our guest presenter for sharing your expertise. And thank you all for attending today. On behalf of ISA, thank you again for your participation.